Hi class. In this video, we're going to be talking about Wronskians, and the reason that we need these is that they're an auxiliary calculation, yet another one, involved in the variation of parameters solution technique for non-homogeneous linear differential equations. So we're just going to jump right in and just show you two examples of calculating a Wronskian. Suppose that you have somehow, magically, you found that y1 was x, and y2 is x cubed. Then what we need to do to calculate the Wronskian is we first need y1 prime, which in this case is 1, and y2 prime, which in this case is 3x squared. And then the Wronskian, w of y1 and y2, here the order matters. I've written it this way to suggest that maybe there's a matrix going on. It's the determinant of the matrix, y1, y1 prime, y2, y2 prime. So in this case, we can just multiply. We're going to get 3x cubed minus x cubed, which is 2x cubed. So our Wronskian is 2x cubed. Okay, let's try a little bit more involved example. It never gets more involved than taking this determinant, but what can get tricky is taking the derivatives. So we'll see one where we have to use the product rule to take the derivatives. Okay, so let's see, we'll have y1 is e to the negative 3x cosine x. And I'll leave myself some space. y2 is e to the negative 3x sine x. Well, the derivative here is going to be negative 3 e to the negative 3x cosine x minus e to the negative 3x sine x. And y2 prime is similar if we have to use the product rule. We get negative 3 e to the negative 3x sine x. In this case, we'll get plus e to the negative 3x cosine x. So when I calculate the Wronskian, which we typically just use w, when I multiply here, I'll get e to the negative 6x times, let's see, negative 3 cosine x sine x plus cosine squared x minus, again I'm going to get e to the negative 6x, and then, let's see, negative 3 cosine x sine x minus sine squared x. And this looks really awful, except we can simplify. And because we use the Wronskian as part of another calculation, you always want to simplify it as much as you can. Here we have e to the negative 6x times, and let's see what happens. Negative 3 cosine x sine x plus 3 cosine x sine x. That actually just cancels. And that leaves me with cosine squared here minus negative sine squared, which is plus sine squared. And we could leave it like this. Actually, that's not true. We can't. One fact that never goes away is the Pythagorean theorem. Cosine squared x plus sine squared x is 1 for all real values of x. So this simplifies actually pretty nicely as e to the negative 6x.